Alright, hi year 11s, this is Mr. Lim here again, and this is a special video for working out ionic equations for acid-base reactions. Okay, so let's just go through all these ionic equation rules. Okay, so first of all, you need to remember, no spectator ions, that's nice and easy. States, alright, you're writing your states. Solids, liquids, and gases, they must stay together in your ionic equations. Weak acids stay together, and they have a double arrow. And a change of state is reacting and therefore is taking part in the reaction. Okay, so let's go through some of the examples in the booklet and go through how to do them together. Okay, so let's go do the first one. Let's just grab this. Let's grab this here and let's do that there. Okay, so hydrochloric acid and sodium carbonate solution. So the idea is that the hydrochloric acid is a strong acid, right? So therefore they do not stay together and it splits apart. It splits apart into its two components, which is going to be H3O plus and Cl minus, because we're using the Bronson-Lowry model. All right, so those are our two things, and we're going to add them to the sodium carbonate solution. So because it's a solution, we've got them there. Okay, now I would not recommend writing out all of these things, but I'm going to show you so that you can see everything, and then I'll show you how you might do it at the end once you've remembered a couple of things. All right, so it's going to form. Now you should remember that your acids plus carbonates make a water plus a carbon dioxide plus the salt. Now the salt that's formed here is going to be sodium chloride, right? Based on the idea that it's the negative ion from that one and the positive ion from that one. So it's going to positive ion that one, negative ion from that one. Now you've got to look at this salt and you've got to go ask, well, is it going to precipitate or is it going to not precipitate? And so you would look on your data sheet and you would say that, okay, then, well, it's not going to precipitate. So it's going to be NaCl aqueous. And if it's NaCl aqueous, it's going to be Na plus Cl minus. Right? So because they're in a solution, they're going to be split up because they're soluble. So therefore, they're going to be spectator ions. So those, that one there and that one there are not going to be included in the reaction. So all you get is this. Get rid of those two. And get rid of those two. And that's your reaction there for that first one there. All right? So no spectator ions, you put in your states, you've got solids, liquids, gases stay together, and your weak acids stay together, but this wasn't a weak acid, and the change of state is reacting. That doesn't really apply to this situation, but it will apply to other ones later, right? So what I might suggest is that you try and do is that when you look at this question, you identify that it's a strong acid, so you can immediately write out the H3O plus, AQ, right? You identify the salt, which is going to be sodium chloride, and then you should recognize that the sodium chloride, both of them started out in ion form, and both of them are going to end up in ion form, so you can skip the sodium and the chlorine, the chloride ions, and then you can write out the carbonate ions, and then you can write out what it forms, and then you can balance the equation. Okay, so you might need 2 of those to make 3 of those, right? And that's a balanced equation. All right, so that's that one there. Let's go do the next one. Okay, right, sodium hydroxide solution and nitric acid. Okay, so sodium hydroxide solution and nitric acid. So let's grab that and put it down here. Okay, so let's go through this one here. I'm going to show you the long way to do it, and then we'll go through the short way, and maybe we'll do, or maybe, yeah, we'll just do the long way as well. So sodium hydroxide solution, so you should recognize it's NaAQ plus OH minus, because it's a solution, right? Plus nitric acid, which is H3O plus AQ plus NO3 1 minus AQ, okay? So you should know from your acid reactions that an acid plus a hydroxide is going to make water plus a salt. So that's NaNO3, which happens to be soluble. So therefore, I'm going to write it as Na plus AQ plus NO3 minus AQ. All right, and so therefore you can see that that is going to be a spectator, that's going to be a spectator, that's a spectator, that's a spectator. Right, so all you really get is OH minus AQ plus H3O plus AQ goes to H2O liquid, and that's two of them there to make it balanced. Right, again, what you should be looking for is you say, okay, sodium hydroxide solution. So it's a solution, so I know that's an ion, that's an ion. Nitric acid, it's a strong acid, so I know that that and that is formed in the ions. What's the salt? Sodium nitrate. I know that that's soluble, so therefore I can skip out doing the sodiums and the nitrates. So when what's left? The hydroxide and the hydronium ion from the acid. And that's what you write out there. Okay, let's do another one. Let's do solid lithium oxide and phosphoric acid. Okay. All right, this might be the last one, and then we'll go squeeze it on another page. Right, so solid lithium oxide. So now it's a solid, it has to stay together. So I know that lithium, okay, I'll just tell you my thinking and my reasoning. Solid lithium oxide, I know it has to stay together. So lithium oxide, I need to stay together. Phosphoric acid is a weak acid, so that has to stay together. Now, this phosphoric acid, you might have seen the hydrolysis reaction as it's H3PO4, right? Plus water makes H2PO4 1 minus and H2O. And that's correct. That's the hydrolysis reaction. Now, but what happens is that when the phosphoric acid reacts with something, because this reaction here is phosphoric acid sitting all by itself with water, right? So this is not having a reaction. This is just sitting in water. This is what it'll do, right? But as soon as you put something else in the phosphoric acid, it acts differently. And the phosphoric acid will act as if it's almost like acting as if it's a strong acid, and it will form PO4 3 minus ions and H3O plus ions there. So the phosphoric acid is going to form phosphate ions, and effectively that affects the salt that it's going to produce. So in this one here, we know that it's lithium oxide, so the salt that's produced is lithium phosphate. Okay, so lithium phosphate, if you check your data sheet, is insoluble. So therefore, solid lithium oxide, Li2O solid, plus H3PO4 aqueous, because we know it's a weak acid, so we've got to put double arrows in, right? It's going to form, because it's an acid plus an oxide, it's going to form water, liquid, right? And it's going to form lithium phosphate solid. Okay, so that means that nothing there is a spectator ion. All of the things are taking part, so we can balance this equation by doing that and that and that, right? And that will be that equation there. So you should look at it, say, okay, I know it's a solid, I know that's a weak acid, I know that the salt is going to be insoluble, so therefore I should write out those three things as one pieces, and then the water there is also formed. Right, let's try the next one. Okay, so let's go grab the next one, potassium metal and sulfuric acid. Okay, so potassium metal, sulfuric acid, let's go move this one across. Let's move it all the way to maybe on this side. Okay, let's move it on to this side. Keep going. Okay, cool. So, what have we got? We've got a metal and a strong acid. So the strong acid is going to completely ionize. And so the potassium metal, it's a solid and it's not an ion, so it's just K solid. Sulfuric acid, I know it's going to form H3O plus because it's a strong acid. I know that the sulfate is going to form a salt with the potassium, so it's going to be potassium sulfate is the salt, right? But I know that potassium sulfate is soluble, so the sulfate ions aren't going to take part, right? But the potassium ions in the potassium sulfate, AQ, the potassium ions here effectively are this and this. And I know that SO4 2 minus ions are there in ionic form at the beginning, right? But the potassium ions, they've changed state. So this is rule number 5 here. where the change of state is considered a reaction. So the K plus ions are shown here, all right? And the SO4 minus are not, because they are spectator ions, because they did not change state, right? And you're going to make H2 gas, and you're going to make water. Well, where did this water come from? Well, you have to have that water because this is the acid. When this donates a proton, what's left? A water molecule, right? So you need 2 of those, you need 2 of those, and that will be balanced, right? Technically, you also need 2 of those and 2 of those, but don't worry about that one, right? Okay, let's have a look at the next one. What's the next one? Carbonic acid and solid magnesium hydroxide. So let me grab that. All right. Let's move across, keep it moving. Okay. All right, so let's go walk through this one. Okay, so carbonic acid and solid magnesium hydroxide. So carbonic acid I know is a weak acid, so I can immediately write that down, H2CO3 aqueous, because it's a weak acid, plus solid magnesium hydroxide. I know I can immediately write that down here, right? Solid, because it's a weak acid, we have the double arrows, okay? Now, if this I know is going to form water and a salt, no, and carbon dioxide. No, wait, no, just a water and a salt, right? So water here and a salt. What is the salt going to be? It's going to be magnesium carbonate. And then if I look at the data sheet, magnesium carbonate is insoluble. So magnesium carbonate solid will be there. And then you can balance out that equation by doing that. All right, so solids stay together. And if it's a solid forming a precipitate, that also stays together. All right, so you need to look at the salt, what's the salt produced, and therefore work out if that's going to be precipitated or not. Okay, let's look at the next one. Ethanoic acid and calcium carbonate solid. Oops, no, where is it? Grab that. Grab that. Okay, let's move that here. Okay, so let's go through that one. So ethanoic acid is a weak acid, so I know that I can write that out immediately. Calcium carbonate solid, I know that that's a solid, so I can write that out immediately. I know it's a double arrow because it's a weak acid, right? So then I need to think, what is the products of this? So it's an acid plus a carbonate, so it's going to make water and carbon dioxide gas. Easy enough. Now, what is the salt produced? It's going to be calcium ethanoate. Calcium and ethanoate, or the negative ion there and the positive ion there. Now, calcium ethanoate is a soluble salt. However, the components of that were calcium and ethanoate, and the calcium went from being a solid to being an aqueous. So that is a change of state. That is a reaction. The ethanoate went from being a weak acid and all stuck together to being an ion, the ethanoate ion, right? So even though this salt is not a precipitate, because its reactants that made that salt were a solid and an aqueous, or a weak acid, therefore I have to show those two things because those were technically a change of state, right? And that CH3COO breaking apart is counted as reacting, right? So I would balance this equation by putting a 2 there, putting a 2 there, and that's it. Okay, last one, right? Let's do the, which one shall we do? Let's do the nitric acid and the copper carbonate. Okay. Let's go grab this, put it over here. Okay, so what have we got? Nitric acid, so I know it's a strong acid, so I can immediately put the H3O plus AQ. Solid copper carbonate, so I know immediately I can put in the copper carbonate because it's a solid. single arrow because it's a strong acid. Right? Now I look at the salt. It's going to be copper nitrate. And copper nitrate is soluble. So since copper nitrate is soluble, it's going to form copper ions and nitrate ions. Now the nitrate ions were ions initially, so therefore they are not part of the reaction. But the copper ions started out as a solid. So therefore, changing from solid to aqueous is a change of state, which means that is part of the reaction. Okay, so the copper ions turn from a solid to an aqueous, so they are included. Then I go through and do my waters and my carbon dioxides because of the reaction. Right, balance this equation, put a 2 here, put a 3 here, and that's about it. Okay, so that's how you do ionic equations for acid-base reactions. A couple of examples. See how you go with the last couple, and then ask questions in class if you need to. All right, adios.